Assalamualaikum warahmatullahi wabarakatuh. My name is Bani. I'm from Numerical Method 02 class, and now I will show my presentation about final assignment project. Um, with the title is Load Analysis on Cantilever Type, Bridge Strategies to Optimize Bridge Design to Minimize Cost using the Python application. The cantilever bridge, and this is the abstract. The cantilever bridge is constructed using cantilevers, which are horizontal structures support only one end. Cantilevers are especially useful for spanning a waterway without dividing it with river piers and equilateral triangles to spread out the loads on the bridge. This happens especially to the members near the center of the bridge. Warren-type bridges are commonly used for means of transportation such as crossing rivers and valleys. To minimize the cost of building a bridge, it is necessary to manipulate height to minimize the volume of the bridge, thus done with the Python app. Next, introduction about cantilever bridge. Cantilever bridge is a bridge built using cantilevers, structures that project horizontally into space, supported only one end. For small footbridge, the cantilevers may be simple beams; however, large cantilever bridge designed to handle road or rail traffic use trusses built from structural steel, or box girders built from prestressed construct. The steel truss cantilever bridge was a major engineering breakthrough when first put into practice, and it can span distance of over 1,500 feet and can be more easily constructed at difficult crossing by virtue of using little or no falsework. The several objectives that are pinpointed in this project are become one of the papers that can be used as learning materials for mechanical engineering students in 2020 in the hope of increasing their interest in the mechanics of material strength and numerical methods courses. And the second, to minimize the cost of cantilever bridge production while still maintaining its strong against the static and dynamic load. This is the model of the cantilever trusses consists of members shown below. They have a well-designed area. We simulate there is a load in each point like the figure below. And this is the tension of this bridge, and this is a compression of this bridge. And this are the expected results that obtain that the obtain of this project is obtain the minimum cost of bridge production, and second, height of the bridge was manipulated and got the minimum volume of the bridge. And next, the data collection method. I will switch to my browsers, and this is my code to my project. I use Python 3, and first we must enter the total number of nodes and then enter the total numbers of elements. After that, enter the x and y coordinate of the node, and after that enter the area of cross sections in millimeter cubic and enter the modulus of elasticity in Newton per millimeter cubic. After that, uh, we will get the element stiffness matrix. And after that, we will input the codes like enter the total number of nodes, select that. After that, and the start node of elements and global stiffness. Then we get the global stiffness matrix of the truss. That we get the global stiffness matrix of the truss again. And this is displacement of matrix of nodes. This is displacement matrix of nodes. We get the 0, 0, 0 minus, and etc. First, this is a force matrix of nodes. We have a 15 sample for matrix of nodes. After that, we get the strength in the elements from 3,168 until 3,744. And this is the stress in the elements uh, in every component. We have 15 sample to this project, and this is force in elements just like this. Uh, okay, we should we switch again to my presentation, my PowerPoint. Okay, the conclusion of this project, I have two conclusion for this project and for this bridge. For this project is the reaction process of which joint can be solved by finding the balance of forces in the x and y direction in this case. To solve this problem is very necessary to master trigonometry. When the equilibrium equation is solved, we get the reaction direction for each joint, and from there we can determine whether an element is in tension or compression. Question like this is tension and this is compression. And with the thrust on the bridge frame, we reduce stress on the bridge frame only in a state of tension and compression. Then the more complex the thrust on the bridge thrust, the stronger the thrust and the more unknown variables. Thus, the method of joint can no longer be used to analyze the thrust. Uh, for for this bridge, I have conclusion like cantilever bridge is different from simply supported structures. Simply supported structures are directly supported at each end, whereas cantilevered structures are directly supported at one end and free at the other end. Uh, and this is my presentation. Thank you for your attention today. Wassalamualaikum warahmatullahi wabarakatuh.